First, the legal disclaimer. I know it goes without saying, but I'll say it anyway for legal reasons. I am not responsible if you burn down your house or burn down your fingers or dump water all over your 3D printer. This content is provided for education, edification, and entertainment. And you're grown-ass people that can take responsibility for your own decisions. Alright, on with the video. I've actually been working my butt off at several different things, trying to keep a couple different balls in the air, but I am continuing with the Ender series and all that. However, one of those is that the freaking hot end cooling fan was driving me crazy. It's amazingly loud for like a 40mm axial fan. So one of the things that I want to do in this series is like mess around with a whole bunch of different like cooling fan arrangements for like if you're printing PLA or something like that. But I needed to take the variable of the fan noise of the hot end cooling fan out of it because I'm going to do noise normalized testing, or at least that's the plan. And B, in the stock setup, you actually get a whole lot of parts cooling from that hot end cooling fan. So I need to take that out of the equation as well. So I rigged up some water cooling setups, intending to go for like what I wanted to do was just do like the cheapest possible solution that worked, like the easiest possible solution that worked, and then do like the best possible solution and then like the bling solution. But it ended up like the cheesiest thing I could possibly do was it's completely sufficient. So I guess the hot end required much less cooling than I thought. This is the stock hot end though, so it is sleeved and all that jazz. So I imagine you need better water cooling setup if you're moving to like a volcano hot end, all metal or something like that. Which we'll get to all that stuff eventually. But since I haven't put out a video in a while, I wanted to take a snapshot of what I'm doing behind the scenes, and obviously there's so much stuff I don't even, I have like buckets and buckets of stuff that I printed out for like various tests, and the printer over there has had a whole bunch of stuff done to it since the last video. But I thought it would be fun to just show you that super janky water cooling setup that actually works. So anyway, here it is. So a lot of you might be asking, like, why am I even bothering with this? Because the hot end cooling seems pretty decent on the Ender. Well, it's pretty decent for typical speeds with typical materials. And by that, I mean, in that like 40 to 60 millimeters a second range for PLA using like a 0.4mm nozzle. As you move to either higher speeds or higher volumetric output rates or both, it starts to suffer a little bit. Plus, if we're looking at different types of materials, it's good for PLA and other lowish temp mats, and it's meh for ABS because you have to more strictly control the fan for ABS, and then for higher temp materials, it's just not a thing that's going to happen because of, well, several factors, but one being that the hot end is PTFE sleeved, which means you can't heat it up beyond a certain point or else that little PTFE sleeve is going to heat up, get gummy, and then deform, and you'll have all kinds of jams and nonsense. But unlike an all metal hot end, it's much easier to keep the hot end cool when you're talking about a PTFE sleeve because it thermally insulates the filament from the hot end or I should say the heat break part of the hot end, or the throat, or whatever you want to call it. So you don't have to worry quite as much about the heat-seeking properties of the radiator part of the hot end. So as far as the stock Ender hot end, it has a large cooling fan on the front, an axial cooling fan that blows across the hot end heat sink to keep it from having too much heat creep and then causing your filament to jam up in the tube. But that also contributes to a decent bit of cooling because the cooling from the axial fan comes in and not only blows back across the heatsink, but also blows up a little bit and spills out the bottom where it's going to cool the parts a touch. Now, there's not a ton of passive cooling from that hot end cooling fan, but there is enough that you can't remove that fan and then evaluate the stock performance of the machine. But one of the criteria for the upcoming fan test is going to be performance as a ratio to the noise performance. So raw performance versus how freaking loud the thing is. Because if you're talking about like the ultimate cooling setup without any regard to cost, space, or noise, well, I mean, obviously you're probably talking about like an industrial air compressor, probably with like a vortex chiller, maybe with like a Venturi nozzle on the end of it or something like that. But we will test compressed air. I seriously, I'm such a nerd, I nearly said Will Wheaton there instead, who is not an air compressor. He's the dreamy-eyed acting ensign from Star Trek The Next Generation. Anyway, back to the Ender stuff. The reason that I say all that is because I had to remove that fan because I need that to be quiet so that I could do noise normalized testing of the cooling, which I mentioned in the previous video, but I'm still trying to hammer out the methodology because the super janky Flapatron 5000, that was just for preliminary testing. I'm obviously not going to use that in the final project, but this is a DIY channel and I'm not rolling in dough, so I'm not going to go out and buy a proper mass flow meter or an anemometer. As the proud owner of more 3D printers than I actually have space for, I have certain things around, namely thermistors, as well as control boards that are already set up for them, and this fabulous firmware that will read it and spit the values out on a little screen for me. Plus, on that little screen, you can control the temperature, you can control the fan speed, the MOSFETs, there's all kinds of power, and it's a friggin' Cartesian robot, so I think that's some useful stuff. Plus, we have this gigantic hot plate glued to it. Plus, I already have that, like, $20 non-contact thermal sensor array that with a little ingenuity I can convert right into a thermal camera. But with all that stuff, I think we could probably figure out a way to do this, he said sarcastically. And hopefully it'll be a way that all of you can test it as well. Because like I said, I don't want to feed people fish, I want to teach them to fish. And despite my massive list of qualification for this type of a thing, there's probably some people out there who will catch something that I missed. But anyway, I figured the best way to eliminate the extraneous noise is to just go ahead and water cool the whole thing. I still have to do something with the power supply fan, but we're getting there. The problem is that like really nice water cooling setups like for PCs and whatnot are stupid expensive. I mean, there are some like radiator blocks that cost more than our entire Ender 3 printer did. But I always keep around little chunks of copper and heat spreaders and heat sinks and that type of thing just in case I need them for something. Plus, I can 3D print anything I don't have, as well as hitting up the local hardware store on Amazon. And actually, in preparation for this months ago, I pre-ordered some parts off of AliExpress for like the priestly sum of like $5 or something like that. But 3 weeks later, the thing hadn't showed up, so I checked on it and they shipped it out into the middle of the freaking wilderness, so I didn't have those parts to play with. I did just get the refund for that though, so that's nice. I'd rather have the freaking parts though. Anyway, I might grab some more AliExpress stuff in the future, but until then we have a couple choices. Full DIY, repurposed stuff, or salvaged stuff. So let's look at a little bit of water cooling theory for those of you who are not in the know, and then we'll get into what I did. There's basically 4 components in a water cooling loop. That's the block, the pump, the reservoir, and the cooler. And the reason they call it a loop, of course, is because you take the water out of the reservoir, fed it through the pump into the actual cooling block. That goes with the hot water taken out of whatever it is you're trying to cool down, goes into the cooler where it's recooled and pumped back into the reservoir. And usually that cooler is some kind of a fan, so the best you can hope for in a water cooling system is a slightly above ambient temperature. And typically what you would do in this situation is figure out what the thermal energy is at steady state and then design appropriately with a system that can take that amount of cooling away, cool it back down to ambient temperature and pump it back into your system again. Or if you're lazy, you could just go for the overkill method and grab a cooler that's much more massive than you would actually need. But that runs into money. And this is a budget printer, so not going to go lazy overkill. Full DIY it is, with repurposed tidbits and thingamadoos from other types of things. Well, we'll get into that. So I figured I'd start with the bottom, with what I think everyone might be able to find and repurpose for a water cooler, and then just make it as cheap and janky as possible, and then see how it performs. Now, the absolute cheapest way to do a cooling block would be just to take a chunk of copper like this and make yourself your own water-cooled heatsink. It's not really that hard since we don't need a whole lot of cooling, but it requires a steady hand and some experience with making deep cuts in metal, so bag that for now. I may come back to that later if I need a higher performance one, and let's talk about just like soldering some pipe together. And this is not a how-to as much as it is what I did, and this is just basically for, demonstration purposes or things like that. I will, as we go along, try to piece together like a parts list for where you can buy a lot of this stuff like cheaper and ready-made so that you can just bolt it onto your printer. So if you're looking to actually do some water cooling, I'd go ahead and hold off until that. But If you really want to do this right now and you like doing the DIY thing and don't mind buying a couple tools, then go ahead and follow along. If you want to splurge a whole $3.60 and buy way more than you need, you can just run down to like Home Depot, Lowe's, something like that, and grab this stuff, which is just 1/4 inch soft utility pipe. Now, this is usually used for plumbing type of things, so you can also buy an entire coil of like refrigerant cooling copper, which is a little bit thinner walled and cheaper like by the foot. You'll also need something to use as the heat spreader, so you can grab this anode material. This is just a strip of copper, and I'll link this stuff in the video description, why not? But you can always just find a strip of copper from something else repurposed. $8 seems a little bit rich for something like this. But this is 2 strips, so technically it's enough to do like 8 hot ends. Same goes for these like 20 packs of heat spreaders. Like these are the smaller ones, so they're not going to be long enough to mount on the screws like I did. But, you know, just to give you some ideas. You'll also need some silver solder. I mean, you could probably use like the regular electronics like lead solder, but that melts at like 185 C or something like that. So if you want to be safe, go ahead and use the silver bearing stuff. As well as a propane torch. This one's super expensive. The one I got was like $7 or something. And then we need to be able to put a U-bend in it, so you can either grab a bender off of Amazon or 3D print a bender, which I did and it worked fine. Or you can kind of do it by hand. Now, let me show you my first attempts at doing this by hand. Fairly certain this wouldn't work, but I had some extra tubing, so I figured give it a try, and just what I expected to happen, happened, which is we crimped it on the bottom. Now, it doesn't matter if you constrict the flow a bit, because we have more flow than we need, but the proper way to do it would be to kind of mandrel bend it. So fill the tube with sand or salt, heat it until it glows dull red. That'll soft anneal the copper. Then quench it in water, bend it around a form until it gets stiff, and then repeat, like re-anneal it, etc. Also, make sure you have a fire extinguisher handy. The way I did it was just spark up the propane torch, grab the tubing in some vice grips that I wasn't particularly fond of, and then just heat it up slowly back and forth until it glows dull red. It should take a couple minutes to get the entire thing heated and glowing, but after that, it should be nice and flexible and you can bend it by hand. After you work it for a little bit, the metal's going to work harden and you'll get to a point where you can't really bend it anymore, and then you're going to have to go ahead and re-anneal it again so that you can bend it again. And when I'm talking about a dull red glow, this is basically what it's going to look like right here, not, glowing cherry red or anything like that. And if you're good for a thin wall copper tube, you should be able to get a bend radius that's about 2 times or so the diameter of the tubing. So I did exactly that. And this was actually bent completely around just with my fingers. And that was really my goal, because I thought, well, if I need to repurpose something to make a hot end from scratch, I can use one of these aluminum couplers and just, solder this tubing onto the end of it. But for startsies, I was just going to use this strip of aluminum, make like a U-bend, and solder it on there and see what happens. So I used my 3D printed bender, and then I wanted to see what would happen if I didn't bother filling the whole thing with sand, if I could get a decent enough bend, and it actually bent really, really easily, and I only had to anneal it once to get this 180-degree bend in it. I was also, if you're interested, for the lazy person, I was also able to fill this with salt and then get the same bend by hand, doing it very, very gradually over like a socket. You should probably use a larger diameter socket than this, and kind of finish things off with my fingers, but I did have to re-anneal it a couple more times to do it that way. Whereas with the pipe bender, you probably won't have to re-anneal it at all because it comes soft already. And it doesn't actually matter if the tubing is not perfectly straight, because we are going to be adding a little bit of turbulent flow into that area, which is good for cooling if it has some irregularities in the surface. So I wasn't too worried about that. And I had to clamp it in a vise a little bit, stick a screwdriver in the end, and bend them out a little bit so that I can get the screw heads in there to frickin' mount it properly. So then it was just a matter of soldering the tubing to the back plate. So as you may have guessed, those 2 holes are to mount it to the hot end mounting bolts. So I just brushed the whole thing with a generous portion of flux, sparked the propane torch back up, and just soldered it right on there. Like I said, I used silver bearing solder, which I had, but you can get it for cheaper than this. And like I said, it melts at a slightly higher temperature, so there's less worries of, dripping solder onto your hot end or something like that if something goes haywire. Plus, it transfers thermal energy, well, a lot better than the lead-based solder, which melts at 185 and only has a thermal transfer of around 35. And blammo, there you go, the jankiest water cooling block ever. Now, if you have a high wattage soldering iron and you didn't buy the propane torch to re-anneal this, then you could probably get this on just fine. I have used high wattage irons to do this type of thing before. It might just be a little bit more of a pain in the butt, and make sure you use a ton of flux. Now, as far as the hydraulic tubing, I just use this clear aquarium tubing, which costs like $1.50 for a roll of like 50 feet or something like that. I took a screwdriver and flared the ends of the copper tubing out a little bit, which isn't tough at all because it's super soft. And I do actually have proper hydraulic couplings for this tubing. I just wanted to go janky at first. Then I stuck a couple pieces of latex tubing on top of that to kind of quote unquote seal it a bit, and then put heat shrink tubing on top of that, which are all things that you very well may have around or can just run down to the local hardware store and grab it. And then just for good measure, I threw some zip ties on there. Now, you could just use like silicone bathtub adhesive or something like that, but I didn't feel like waiting 24 hours for it to fully cure, and I wasn't sure if I wanted this to be permanent or not since I wasn't positive that it would work. Ends up it did, so go ahead and use that kind of sealant if you want. I also soldered this other piece of copper onto the top. I figured while I was brazing stuff, I might as well go ahead and do that just to be a fancy boy. Also, so I can get it to sit flush, I went ahead and shaved this little grub screw down with a file. Now, you could always just flip the hot end around to the other side, but I couldn't be bothered. And then that little snippet of silicone I mentioned before, this is where I put that. I just cut a little notch in it and stuck it on top of the heating block. Finished. Now we just have to look at the other parts. Since we're economizing this whole thing, I thought we don't probably need, at least for the stock configuration, a lot of thermal energy transferring ability. So I figured we could probably just roll the reservoir and cooler all up into one. And I just ran down to the thrift store and I grabbed an aluminum cup for like 99 cents that I could use as a reservoir, and then that would also be, the surface of it would be a heat sink to the ambient air, and I didn't bother putting a fan on it. I also have some of these little tech plates to mess around with, and I didn't use those, but before anybody asks me in the comments, I do have some of these techs to play around with, and they cost like a couple bucks a piece. They are low efficiency, but it's highly localized cooling, so I thought that might be a good thing. Maybe we'll use them in the future, we'll see. And then for the mount for the reservoir, I just 3D printed a cap, and I 3D printed basically a cup holder and just mounted it right to the top of the printer, ran the aquarium tubing out of the bottom, and there you go, reservoir and cooler is all finished. So now we just come down to the pump. Now, I actually looked at like the cheapest pumps on Amazon that I could find, and I grabbed this one, which is like, $8 or something. I grabbed it because it's a 24 volt pump, but I didn't actually end up even needing that because this itty bitty little like 5 volt pump or whatever actually put a whole lot of fluid through there. And these are just for running those little like perpetual fountain gizmos and things like that. But when I build like a bigger, badder cooler, then I'll probably end up using this guy. So I'll link that in the video description below as well. This pumps a whole lot more than the little one that I'm actually using. And there we go. This is our entire loop. Now I know it might not look like much, but it actually functions pretty well. For initial testing, I just sit it here, heated up the hot end to like 200 and something and just let it cook for a couple hours while I watched The Witcher. And it never even got warm-ish to the touch. It was actually still cool to the touch. So I figured, hey, why not go ahead and print some stuff? So the first thing I actually printed was this stupid like dual blower fan shroud thing that I just slapped together in CAD because as I found out, this little cooling fan on the side does basically dick. The horrendous quality of this print will attest to that. But in the entire print, it barely got above ambient temperature, and then I've literally printed dozens and dozens of things with this setup. Since then, I'm still printing with it right now, and I haven't had a single problem. I bought a little bit of a time until some of the other parts come in, but if you want a fun little DIY project and you have a hardware store available to you, here's the general list of what you would need. Now, as I said before, I would wait until I get an easier setup together. It'll probably be cheaper in the long run, but if you really want to do it, this is the stuff you'll need. And although I did this for future testing, let me show you the glorious, glorious silence that we get. Here's a little before and after. So first we'll do the before with the stock cooling setup and then the after with the water cooling setup. So thanks for checking out the video. Hope you dug it. I haven't had as much time to go through questions and answers, but I'll try to do that as I can throughout, like, you know, the holiday and the new year. You know how goofy it gets. And I will have coming up like a question and answer, because I never did a question and answer for November, and like a year-end wrap-up type thing like I did last year. Check out support links in the video description below. And until the next video, get out there and make something awesome.